Hello and welcome to this CATIA instructional video on prismatic machining. We are working on our example part here, trying to program the hole operations. In the last video we looked at how to center drill, and now we're going to move on to how do we go about drilling out these holes. In the previous video we measured these hole diameters. We found that these holes on the lower flange were ½ inch in diameter. And then these holes here on the top part of the design were actually 27/64. In the end, they're going to be tapped to give a half 13 UNC thread. So the drill size for holes of that size is 27/64. So let's go ahead and start inserting our drilling operation. There are a number of different types of drilling operations that are present here. For these holes we're going to use peck drilling, and to do that we're going to use the drill deep hole operation. So let's go ahead and select this, and we're going to have to do this in two operations because the tool of course is different. The tool size between these two are different. Let's go ahead and start by doing the holes on the bottom flange. So again, I'm going to click first on the spot drilling operation, the last operation in 3, to insert the drilling operation there. And again, we start off on the second tab. Here's our image. So we have our entry surface. We have our hole locations, which is defined by this, the size of this hole here, and then the bottom. Now these are true holes. The holes go all the way through. So we notice here that there's this toggle up here. Right now it's set to blind. If we click on this, it toggles to true, and we now have a true hole. And we now have, we have an additional surface that we need to pick to indicate where the drill breaks through. So let's go ahead and pick the surface that the holes are in, which is the same thing we did for center drilling. So I've clicked the surface, and I'm going to double click. And then I'm going to click on the wall here, the red line on the wall. And just like with the center drilling operation, I have the option to use a pattern. So again, if you hold on the control button and the middle mouse button, you can zoom in and make the tree look larger. Notice that in addition to the part where we have that rectangular pattern, we also now have the patterns that were created previously, these machining patterns. So we now have a machining pattern for the center drilling operation that we can reuse also. I'm just going to use the pattern in the tree. In the part, sorry. And here it is. So we have all 6 holes selected, and the sequencing is the same as what we had for the center drilling operation. So let's hit close. And then I'm going to double click in the background. So we have everything selected here except the breakthrough surface. So let's go ahead and select that bottom line, and then we're going to pick the bottom surface of the part to indicate that that's where the tool is going to break out of the bottom. So we now have our geometry selected. Let's move on to our third tab, which is our tool selection. So right now CATIA is thinking that we're going to use a center drill to drill these holes, which of course is not possible. So what we're going to do is we're going to select a tool from our resource list. Again, those tool holes are ½ inch. So we're going to need to use a ½ inch twist drill to do this. And if we look up here, we actually don't have a half inch twist drill. So we're going to have to add a drill to the tree. So let's go ahead and do this. Actually, the way I'm going to do this is by first of all selecting the 27/64 drill, because this is very similar in size. So I may not have to change as much information in the tool. So let's go ahead and add that, or select that. So let's come over here and select a tool from the document. Let's select our 27/64 drill. And then in order to create a new tool, what we would simply do is we would simply change the name of the tool. So notice as I start changing the name here, these fields here get grayed out because I'm going to have to edit those in a second. So I'm going to just change this to ½ inch. And I'm going to remove what's in parentheses here because it's going to be exactly ½ inch. And then the tool number is going to have to be different. So if you recall, we used the last tool number that we used for the center drill was tool 3. So what we're going to do is we're going to use tool 4 for our 1/2 inch drill. So notice if I hit the tab key, it actually indexes to tool 4. Or actually I removed that one. So we're going to leave it as tool 4. And notice here that we now have that drill added to the tree. So there's now an additional tool being added. And again, that's due to the fact that we changed its name. CATIA is creating a new drill for us based upon the information that we're putting in. If we hold on the control button and the middle mouse button and zoom in, we can see the parameters on the drill. The main thing that we want to change here, of course, is the diameter. So this is 27/64. We can either double click on this, or if we go to the More window, we can change the body diameter here in the text field. So I'm going to change it in the text field from to 1/2 inch. And that actually changed the body or the shank to change the actual nominal diameter, which is what this D value is. Notice the value here in parentheses. I need to change this too. So I'm going to change both of those, the shank and the actual nominal diameter, to 1/2 inch. So I now have a 1/2 inch drill diameter. If we look at the other tabs over here, I probably don't need to change too much. Again, the drill's 27/64 is almost 1/2 inch. So if we look at the technology, again, 2 flutes, high-speed steel, none of this changes. It's a right-hand tool. And then if we go to feeds and speeds, the cutting speed is set to 1,000 RPM, and the feet per toot is 1 thou per turn per toot, and then the actual feed rate is given here, grayed out, calculated from this, as well as the speeds, the cutting, the spindle speed. So again, I don't think we need to change these. These are very similar because the sizes of the two are the same. So that's our tool. We've now created a new tool. If we go over to the 4th tab now, the process parameters, again, we have the approach speed, we have the plunge rate, and then we have the machining speed. And again, the machining speed is 3 inches per minute. This is a little bit slow. We could potentially increase this a little bit. So to do this, if we want to override what's in the tool, we can do this by unchecking the checkbox here. And we can probably go up to 5 inches per minute. So it's a little bit faster for our actual machining. So we've overridden what's in the tool, made it a little bit faster. And then our machining speed is at 1,000 revolutions per minute. So that's our process parameters tab. And then we go over to our approaches and retracts. And we're going to do the same thing that we did for the center drilling operation. What we're going to do is activate our approach, activate our retract. And our approach, we're going to set this as an axial move at 100 thousandths. And then the retract, we're going to do the same, an axial move at 100 thousandths. We're going to activate our linking. So because we're linking again between holes, we're going to again use an axial move of 100 thousandths. And then for the approach, we're going to use the same 100 thousandths axial approach. And again, we should also activate our clearance move because we're going to run into the same problem we had with center drilling. The tool is going to run through the part. So again, our clearance move will force the tool up to the global safety plane, which is positioned 100 thousandths above this plane. We said that in the setup. So let's go ahead and activate the clearance move to make sure that the drill is moving and not running into any parts of the part. So that's our our 5th tab, and now we double back to our 1st tab. And here we get to set all the different parameters for a peck drilling operation. So it's a little bit involved, this picture, but we can see the approach clearance is set to 50 thousandths. And again, this is what we set in the center drilling operation. which means that that's where the actual feed motion is going to start, where we change from the approach feed rate to the machining feed rate. So let's leave that as is. We're going to go by tip, so we're going to program the depth of the tool by tip. Because we are machining a through hole, which is shown again on the second tab, we're going to have a breakthrough distance that we need to set. So let's go ahead and set this to 1/8 of an inch to make sure that the tool tip goes all the way through and the edge of the tool goes through to give us a full hole depth. The maximum depth of cut is DC. So if we look at this here, this indicates how deep do we want to go on our peck depth. So if we look more closely at this picture, what happens is that the tool will advance, cut to this depth, and then we see over here we have a retract, and then the tool is going to re-engage or plunge into the hole. It's going to stop a distance which is indicated by OR, that's called our retract offset, and then it's going to move into the machining feed rate, and it's going to go down and it's going to cut this DC down to this position here. It's going to retract up to the approach clearance plane, and then it's going to wrap it back down, stop a distance OR above where the tool was previously, and then it's going to feed down to the next depth. So these are your these are your feed motions here, and of these feed motions, the first part of it is in air, and then it hits material and it actually does the actual material removal. Okay, so again, the maximum depth of cut, we're going to set this to 1/8 of an inch. So again, that's how much the tool is going to plunge into material each time so from here, the surface to 2, from this level here to 5, and from this level here to 8. So that's that distance there. The retract offset, let's set this to 50,000. So this is how much air the tool is going to feed through before it hits material. And then the decrement rate, this is an option that we can do if we want to reduce the amount of the actual peck depth as we get deeper and deeper into the hole. And we don't really want to do that in this case. We just want to use a constant peck depth. So this allows you to have a variable peck depth with it reducing as you get deeper into the hole. So let's set that to 0. And the decrement limit, I believe this has to be something other than 0, but this doesn't come into play if this is set at 0. The other options here are not really that important for what we're doing. So let's go ahead and generate the tool path. And as we can see here, we see that the tool path looks very similar to what we had for center drilling starting here. Let's just rewind and go to point-by-point replay just to look at what happens for the first and second hole. Here's our rapid from the clearance, the global clearance, down to the start of the approach. And we should see the tool switch into approach mode now. So here's the yellow. And then it stops 50 thousandths. So that's that A parameter that we just specified. And now it changes into green. So notice that it did the first peck going down 1/8 of an inch, retracts upwards. It rapids downwards and it stops 50 thousandths. That's that OR value. And then we go an additional distance down 1/8 of an inch under feed mode, retract back up. It goes all the way up to that 50 thousandths clearance plane that we set. Rapids down, pecks, retracts all the way out, and then it rapids down, feeds back up, and then here's the last motion. Now if we look at this closely, we'll see that the tool did not go far enough through the breakthrough. So the edge of the tool, you want the edge of the tool to go past the bottom of the hole. So that's the last step. The tool is now going to go back up to clearance and then reposition to the second hole. So there is an issue there in terms of maybe we didn't specify the enough of a breakthrough. So we specified, I believe, 1/8 of an inch. Maybe we need to go more like 1/4 of an inch even, or at least 0.2 to get the tool all the way through. So we need to change that. Before we do that, let's just step through. Actually, let's switch back to continuous replay and just run the tool through. So let's go back and change the breakthrough B. So our breakthrough here is, scroll up, set to 0.125. Let's go to 0.2 and see if that gets us through. Let's replay. Let's rewind. Let's go ahead and again go to point. I'm going to go into front view here. So here we go again. And we're still a little bit, no, there we go. So we are going all the way through. So now you see that the edge of the tool now goes all the way through past the bottom of the bottom surface of the hole, which is what we want. Let's just look at material removal. I'm pretty sure that we don't have any collisions happening because of the clearance plane that we've set. Let's go back to continuous replay, and we're going to do video from last save result. So the last save result was all the milling operations and setup 2. So we will see the center drilling, and then we will see the drilling. So here's the center drilling, and then there's our drilling operation. And the tool is stepping over and not colliding with the part. So we have our first set of holes drilled. Let's go ahead now and look at the second set. So we're going to go ahead and let's just go ahead and select the deep hole operation from the 3. And we're going to switch our type. This time the type of hole, the extension is blind because we do have a bottom to these holes, so we're going to leave it as is. Let's pick the top surface and then double click in the background. Let's go ahead and pick the holes. Now there isn't a pattern for these, so we're going to have to go through and just select each hole. And then double click in the background once we're done. And then for the depth of the hole, we have the option to actually select, if it's a conical surface or even a flat surface, we have the option to pick that. So I'm going to pick this conical surface to define the bottom of the hole. So I don't even have to have it measured. CATIA actually figured out from here, from what I picked, that the hole is 1.25 deep to the shoulder of the hole of the bottom, so not including the tip. So there we have defined our various hole locations and our various hole parameters. We do want to switch the drill, so we want to switch from the 1/2 inch drill back to the 27/64. So let's go ahead and do that. And we want to change the tool number to number 5. So this is the 5th tool. It will be the 5th tool that we load on the machine. And again, all the information about the tool should be set up since it was loaded in from the catalog. We move over to our cutting parameters, and again, these are copied from the tool, and these look fine. And then our approaches and retracts, CATIA, as I've mentioned in previous videos, typically copies in the approaches and retracts from the same operation as they were set in the last time that operation was created. So these are similar, or they are the same as the operations that we set for the 1/2 inch drill previously. And again, we're going to work with these. We're going to stick with these for machining up here. And then our strategy, Again, if we look at this, this is the same too, because again, we're using the same type of operation, the deep hole operation, deep hole drilling operation. So these again are copied in from the previous drilling deep hole operation. So let's go ahead and generate our toolpaths. So again, notice that because we did a tool change, there is no real benefit from where we start, because the tool is coming from the machine home position after we put away the previous half-inch drill. And again, we can go ahead and, using the video from last save result, we can run through there we have our holes drilled. You can see that they're drilled to the depth that we selected by selecting that conical surface. Okay, let's hit OK here. To summarize, this video showed you how to add drilling operations. Drilling deep hole is the operation that we used, and this is similar to the peck drilling operation that you're probably familiar with. In the next video, we'll look at the remaining two operations that are left on this part, which is the counterboring operation and then the tapping operation to put treads on these 4 holes.